In this lecture, we'll explore joins and advanced topics in the Basics Plus SQL course. Breaking data into multiple tables enables for more efficient storage and easier manipulation and greater scalability. But this comes at a price. So when you need to retrieve this data that's stored in multiple tables, then you can use a join in the select statement to retrieve the data. So using a special syntax, you can combine the data from multiple tables and retrieve it as a single data set. There are different types of joins. This is a left join, inner join, right join. This is the left outer join, full outer join, and the right outer join. These are the 7 possibilities. And of these, the inner join and the left outer join are the most used ones and the most popular ones. So we look at what each of these does. The inner join operation merges the rows from 2 tables, and the rows that are retrieved are the ones that are common to both these tables based on a specific column that's used as an attribute. The foreign key in the first table, which corresponds to the primary key of the second table. So let's take a look at an example of an inner join so it's a little more clear. So here we have a select statement where we are selecting from the departments table and the employees table. So we are doing an inner join between the employees and the departments tables. We are joining on a specific column, which is the department ID of the employees table and the ID of the departments table. So the department ID is the foreign key in the employees table, and in the departments table, it's the primary key. So that's how these 2 tables are related. And when we're creating the SQL statement, we have to specify in the from which tables that we are merging, and then on what column we are merging on. And at the same time, we also have to specify the equality or the inequality sign. For the outer join, you get the same result as the inner join plus some additional rows, if there are any. So if you're doing a table A, left outer join, table B, then you'll get all the rows that would be returned in an inner join clause between those 2, plus you'll get all the other rows from the table A as well. But you won't get any rows that are not joined from table B. So this is an example of a left outer join. So in this case, we are again joining the employees table and the departments table. Here we are doing the left outer join, and again on department and department ID. So in this case, we're going to get all the data from the left table, which is the employees table, and then only the matching results from the right table, which is the department table. So here we have an extra row in the employees table, and that doesn't correspond to any that are matching from the department table. So in this case, what we got is there is this one person, this one employee who does not belong to any department. Now we can also do a cross join, which is basically a Cartesian product between 2 tables. So if you do select star from table A, cross join table B, then you'll get the Cartesian product of like all the rows from table A times all the rows from table B. Now a correlated query is one where the subquery references variables from the upper query. The subquery has to be repeated for each row of the upper query, and it could be rewritten as a join. In the case of an uncorrelated subquery, this calculates a constant result set for the upper query, and it can only be executed once. Lateral is a newer type of join method. It allows a subquery in one part of the from class to reference columns from an earlier part of that same from class. So the lateral is useful when you're using cross joins, or if you're cross-referencing the column and you need to be able to compute or get the computed value in order to use for a result set. Adding the lateral syntax, you can reference that item in the outer query and it will be pushed into the inner query. So let's look at an example here. So the left one is a normal query. You can correlate a sub-item from the outer query to an item in the inner query. And this is the typical correlated subquery that we talked about earlier. So you have select dname ename from department D, where ename in select ename from the employee table E, and then you're joining department number and department number from the employee and the department, and then you order 1 and 1. Now, if you use the lateral, what's happening here is you're able to reference that item in the outer query, which is the ename, direct from the outer query, but after having it calculated from that inner query. So these are functions that show if something exists or not. So the exists function in SQL is used to check whether the results of a correlated nested query is empty or not, and the results of the exists is a boolean, so you get a true or false. Exists and not exists are typically used in conjunction with the correlated nested queries. So when you're using joins, you have to pay attention to what type of join you're using, the join syntax, because that can be different in different systems. You want to make sure that you're providing a join condition, or you'll just get the Cartesian product as you saw. So you can also include multiple joins and join 3 or 4 tables in the same go, but that just makes the query complicated and it's a lot harder to troubleshoot it. Union. So SQL queries can be combined using the union operator as well. So if you have 2 separate SQL queries and you want to combine them, you can use the union operator. So here you have select name job salary from employees where salary is greater than 3,000, and then you have a second select statement, select name job salary from employees where job equals clerk. So when you do a union, it basically gets the results from the first table and then combines it with the results from the second table. CRUD. So what's CRUD? So if you look up CRUD on Wikipedia, you get a number of different definitions. Waste, dirt, feces, or something of poor quality. Create, read, update, and delete. Basic functions of a computer database. CRUD, the game played on a billiards table, which was invented at the Royal Navy in Canada. And CRUD is also apparently the name of a radio station, or a former radio station from a college in Toronto, Canada. So one of these is, I guess, relevant for us, which would be the second one. It's also the name of a character in a cartoon, so quite a famous term apparently. So CRUD stands for create, read, update, and delete. These are the DDL, the data definition language. Create table, create view, create index, create procedure, and then you have alter table, insert, update, delete. So the first 4 are procedures, commands that you can use to manipulate the database tables. So the create table creates a table, create view creates a view, create index creates an index, and create procedure creates a procedure, a stored procedure. Alter table is used to make changes to an existing table, the table structure. The insert, update, and delete are row level functions. So insert, you're adding a row to a table. Update, you're changing a specific row in a table. And delete, you're deleting a row in a table. So if you're looking at the create part of the CRUD, these are the 4 for the table. And for the insert, the syntax is insert into table. You specify the column names and then the values that you want to insert. For alter table, this is to change the structure of a table. So in this case, we are adding a new row in the departments table with the name of sales and Berlin. So we're adding a new sales department to the departments table. So in this case, we are doing an alter table. So here we're changing the structure of the employees table by adding a new column called fav color to indicate the favorite color of employees. And we are saying that's a varchar of 40 characters, and the null means that that column can accept nulls. and the position of that new column should be after the salary column. Then you have the update, which is updates the row. So here we're saying update the employees table and set the salary to $1 million where the name is Jonas. Then you have the delete. Delete also has two separate versions here. So the drop is a database level command that you can use to drop a table or a database object, and delete is a row level command where you're deleting a specific row from a table. So when you're using delete, you can delete specific rows from a table, or you can delete all the rows from a table. So if you want to delete all the rows from a table, you can use the truncate command instead of delete. So the difference here is that truncate will not write to the log, so you can't undo it in case you're deleting by mistake. But the operation itself is a lot faster than using delete. So you can think of it as if you're deleting something from your computer, it's you can choose to send it to the trash, to the recycle bin, or not, or delete it permanently. In transactions, if you're using transactions, then you can use the commit and the rollback. So in this case, you can specify the commit while you're performing a certain update or delete or insert statement, and then if you wrap it in a commit, then you can always roll back in case there's a mistake or in case there is an error or you want to undo it. Views. So views are virtual tables. Views contain queries that can dynamically retrieve data from the underlying tables. So MySQL does not support views. It depends on the system that you're using. Views are used quite extensively in Microsoft SQL Server as well as Oracle, and especially in large banks and insurance companies and all these Fortune 100 companies. If you look at any of their databases, it's going to be filled with a lot of views, but MySQL does not support it. So there are a lot of advantages of using views. If we're reusing the SQL statements, we can simplify the complexity of a query because we are creating that query first to retrieve a certain view, and then we can perform other queries on top of the view and treat it as a table. It also provides a good security layer because you can give access to users for certain views where you're not showing some columns, for example. So in that case, you don't have to give access to the entire table to a user where there might be some sensitive data that's hidden in some of those columns. So when you create a view, you can choose to discard those sensitive data columns. The views can also be presented in a much nicer way, in a more user-friendly way, as well as in a productive manner, in terms of, for example, certain calculations or merges and so on. So once a view is created, you can basically use it as a table. There's almost no distinction. So you can perform select queries, you can do filter, sort, where, and you can join views, and you can join views to other tables. In some cases, you can also do updates. But views don't contain any data. Any data that's retrieved to execute a query must be processed every time the view is used. So the view is not storing any of the data. So that whole calculation is being done on the fly. So if it's a complex view with a lot of joins and filters and nested views, then it's going to be a performance issue. On top of that, if you're using a view to join other tables and other views, that just adds to the complexity, and that becomes even more of a performance issue. Constraints. Constraints help count the database data when it's inserted or when you're making changes to that data. So relational databases store data broken into multiple tables, as we've seen. Each table stores related data. The keys are used to create references from one table to another, and there are different types of constraints that you can apply depending on the RDBMS. So the main four constraints are the primary keys, foreign keys, unique constraints, and check constraints. So primary keys are the most important things. It's a special constraint that's used to ensure that the values in a column are unique and they never change. no two rows can have the same value. Every row must have a value. You can't have nulls, you can't have an empty value, and if a row from the table is deleted, that primary key can't be reassigned or be reused for any new rows. This is important for auditing purposes as well. Foreign keys. The foreign key is a column in a table whose values are the primary key in another table. So in our example, we saw that we have the employees table and we have the departments table, and we saw that the primary key from the departments table is the foreign key in the employees table. And that's how we were able to join them together. So unique constraints. You can assign a certain column and say that only unique values are allowed in this column. So that's basically a unique constraint. So once you set that constraint, then any new data that's being added to that column needs to fulfill that requirement. Primary keys are automatically have a unique constraint because you can't have different values in the primary key. You can't apply the unique constraint to define foreign keys. Check constraints. These are used to ensure that data in a column meets a set of criteria that you specify. You can set constraints to check for a minimum or maximum values, to specify ranges, and to allow only specific values. So this is sort of a data validation type thing that you can do that's custom to whatever needs that your business may have, and you can enforce, for example, a certain data type that can be inserted into a certain column. So you can force a certain format even and say, okay, only Fahrenheit data can be inserted into this column and no centigrade. So when data is stored in a database, you perform queries to retrieve the data. The database system is using certain methods to optimize those queries in order to retrieve the data. So if a column is indexed, that means it's sorting. So it's internally sorting that. So it's internally sorting that column, and it's going to be much faster to retrieve data for the database system. So primary key automatically has this. The primary key automatically has an index. And when you're searching for a column that has an index, that's going to make the query much faster. In addition to the primary key, so you can create an index to one or more other regular columns in the database system. After an index is created, it will search and sort that index to find the locations of all the matches. You can think of it as a mapping. The indexes do degrade the performance of the data that's being inserted, modified, and deleted. Because every time you make a change to a column that has an index on it, then the database has to reevaluate and reshelf or resort all the data internally in order to keep the index up to date. Not all the data and data types are suitable for indexing. And you can also combine multiple columns and create an index based on that. A stored procedure is a subroutine. It enables applications to access the relational database tables. As the name implies, it's a procedure that's stored. So in this case, you can think of it sort of like a view, but in this case, the stored procedure is already compiled. So it doesn't need to be re-evaluated every time you call it. It's more like a black box in this case. If tables, column names, or the business logic changes, then you only need to change the stored procedure code and update that. Stored procedure also helps with security because it's encapsulating the code, and then you can protect the stored procedure so people can't really see the underlying code that the stored procedure is actually, or the query that's behind that stored procedure, because it's compiled. Triggers. Triggers are special stored procedures that are executed automatically when a certain criteria is met. So this criteria can be database activities that are associated with insert, update, and delete operations. A typical trigger has three components. There's an event, a condition, and the action. So the event is when the trigger should fire, and the condition is whether the rule of the action should be executed or not, and the action to be taken is what should actually happen when the trigger actually fires. So for example, you can set a trigger saying that whenever a new row is inserted in a certain table, send somebody else an email. Create a trigger saying whenever a row is inserted into a certain table, automatically a stored procedure should be fired. Database security. Database security is a separate complex topic, and you can take a separate course or entire sets of courses for that. So you can perform some security operations using SQL. So you have the grant and revoke statements that you can use to add permissions or revoke permissions to users. Also, one of the biggest vulnerabilities in databases is called the SQL injection. So this is malicious code that can be inserted into strings that are later passed to a RDBMS for parsing and execution. So this is how the SQL injection works. For example, you have a login form on the internet, a typical login form with a username and password. Then a regular person would usually type in their username and password, press login, and that would authenticate the user and provide access if that's successful. Now a hacker can come in from the middle, type in some SQL code directly in the form itself, and then bypass the authentication and authorization, and the database will automatically authenticate the person because they're using, for example, in this case, they're doing select star from users where user ID equals blank or 1 equals 1. So as we've seen very earlier on, when you're using the OR function here, the database system only evaluates one part of it. As long as one of it is true, it's going to pass the entire SQL statement and treat it as a true statement. So there are several ways that you can mitigate this attack. So one of them is detection. You can detect that this vulnerability exists by using database firewalls. Another way is using parameterized statements. So you had to actually provide parameters more than just the 1 equals 1. You can fix this at the coding level by escaping or by pattern checking.